The difference between analog and digital is often talked about. Analog amps sound better, film cameras look better than digital cameras, and so on. But what even is digital? Most people know that digital has something to do with computers, but why does that make it better or worse at different things? If I had to explain it in one sentence, I would say that analog is a continuous gradient of colors, while digital is a whole bunch of unique colors with fine lines between them. But why is it this way? Well, let me show you an example of how these two methods do what they do using light bulbs. You may have encountered lights in a house that use circular knobs to change the amount of light being generated. As you turn the knob, the brightness of the bulb goes up or down. This is great because you can choose exactly how much light you want. It has a seemingly infinite number of states it can be in. This is analog. Now, a light switch only has two states. It's either on or off. 0%, 100%, nothing in between. So the light switch is far inferior to its analog counterpart, right? But what if we had two light switches, with each one providing 50% power to the same bulb? If we only turn one switch on, we would get half light. If we turned both on, we would get 100% light, and if we turned both off, it would give us 0 light. Now we have three states that can be represented with the switch method. But that's nowhere near as good as turning the knob. So let's add switches. If we had 4 of them, we could make each one provide 25% power. We now have 5 states: 0, 25, 50, 75, and 100. Better, but still nothing close to that continuous gradient that the knob gives us. But we can actually rearrange these 4 switches to give us far more options. If the first switch provides 50% light, the second 25%, then 13, then 12, we have way more options with the same amount of switches. If we want full light, we turn them all on. If we want 75%, we turn on the first 2. If we want 63% light, we turn on switches 1 and 3, or if we want 12%, we only flip the last switch, and so on and so forth. If we wanted even more specific intervals, we could just add more switches with more unique values until we had literally one as small as 1%, or even less. With this setup here, we could have any whole number between 0 and 100, and even a good bit more than that. This is digital. In fact, this concept is exactly how binary works, as I've talked about in my earlier video. But instead of light switches, it's with microtransistors. Each switch represents an increasing power of 2 here, so you can turn them on in any combination you need to get the number you want. This is exactly how computers do what they do. And it's what those ones and zeros in binary represent. But this still isn't as good as the knob. The knob is so precise it can go in between whole numbers and get things like 13.4% or 56.325% and so on. This is because the knob is a mechanical device that is changing the amount of current being fed to the bulb. It's the same concept with volume controls on a tube amp or the brightness settings on a film camera. For digital to compete, it can just keep adding more and more switches to make it more and more specific, but how specific do we need to get? Even really good digital systems with dozens of switches dedicated to a single value don't represent anything close to the amount of information present in the real world. With a picture, for example, a computer can use this switch method to make any single pixel represent millions of different colors. But the wavelength of radiation in the visual spectrum, which is what allows us to see, is a continuous gradient. So the actual amount of unique color shades is practically infinite. The most advanced computers can keep track of time down to billions of ticks per second, but atomic clocks put this to shame with quadrillions of ticks per second. While the shortest possible amount of time, a Planck length of time, fits into 1 second 10 to the power of 43 times. The point is that on any kind of digital spectrum, be it color, sound, or time, no matter how specific it is, if you zoom in far enough, you eventually see blocks. Fine lines where one color becomes the next, because they're being created using the switch method mentioned before, which runs out of in-betweens at some point. If you zoom in on an analog spectrum, you just get a more and more precise spectrum, all the way down to atoms. It's the same story with sound. Digital speakers use this switch method to determine how loud and what pitch a sound is, while a record player changes the amount of electricity being fed into a speaker based on an arm that moves up and down. This is just like turning a knob. This means that it can be as precise as the physical reality that we live in allows it to be, while digital sound is restricted to how many combinations of switches are available. Now keep in mind, digital images, sounds, and the like are getting to a point where humans can hardly tell the difference between them and analog, but technically, analog will always be more precise because it's based on the functions of the real world. So knowing all this, why did we decide to use digital systems to make computers? Well, it's because of reliability. For the first few decades of their existence, computers weren't used to display images or make sounds or anything like that. They were used to store data. Bank accounts, social security numbers, math equations, documents, things like that. Now, for this job, the switch method works way better because it is reliable. An on switch is definitely on, and an off switch is definitely off. But an analog knob that mechanically changes the amount of current being fed to a circuit is impossible to distinguish. With something like writing, there is no halfway between the letters C and D. Each letter is either one or the other, and you want to make sure it's known to be one or the other. You don't want a gradient to represent these things. You want something with clear, specified lines, like digital. It's because computers are based in numbers that they generate sound and images the way they do. Computers are just information machines that were eventually converted into creative tools. The computer isn't so much able to create the image as it is able to tell your monitor how to create the image. If analog is me handing you a picture I drew, then digital is me telling you exactly what color each pixel in that picture is and in what position. Digital devices instruct things on how to make pictures and sounds, rather than making them or storing them themselves. If you want to know a bit more about this topic, my videos on how binary works and also on how voltage states work are both closely related to the topic. Liking, commenting, and subscribing are always a huge boost, and as usual, thanks so much for watching. I hope I helped, and I'll see you next time.